Hello everyone and welcome back. I'm Matias and I will be your host for this episode. This is how to make a Metroidvania Part 4, where we'll be teaching you how you can create a Metroidvania like Hollow Knight in Unity. In this episode, we'll be creating a heart UI system, spellcasting, and mana system. These mechanics will give the player more options for gameplay, making it more interesting to play. Before we jump into today's content, we'll be making some improvements to what we created in the previous episode. Firstly, we'll change the health system to one that's much simpler. In the player controller, we'll remove the clamp health function and all its references. We'll create an integer property health and return health. Then, if health is not the same value as the health property value, set health to the property value. Now, we'll change all the times we reference the health to the health property instead. Next up, we'll be updating the attack input to use the input manager instead of using the mouse input directly. In the input manager, change this fire 1 to attack. We'll be using the left mouse button for the input, so we'll add in mouse 0. In the player controller script, change the attack input to the attack input from the input manager. Next up, we'll create a void FixedUpdate and move Recoil there. Then, we'll return the dashing state. This is because FixedUpdate is affected by the timescale, whereas update runs every frame regardless. So if the game is paused, we won't dash or recoil. Next, we'll be adding a particle hit effect when the player is damaged. Create a particle system and name it Blood Spurt. Do note that the following particle effect settings are the ones I'll be using, but feel free to use your own. We'll change the duration to 0.25 seconds and uncheck looping. Then, change the lifetime to 2 and speed to 75. Change start size to between two constants, 3, 8. Decrease the gravity modifier to negative 0.7. Decrease the max particles to 30. Then change the rate over time to 1000. Change the shape to circle and reset its rotation. Shape scale to 0.25 for Y. Next, change velocity over lifetime to world and check size over lifetime. Next, we'll create a material, blood material, and change it to particle standard unlit. And drag in the particle from the night asset pack into the albedo and change the rendering mode to cutout. Assign the blood material to the particle system renderer. Finally, we'll make both the blood material and blood spurt a prefab and recenter the blood spurt. Create a game object, blood spurt. Then in the stop taking damage coroutine, we'll instantiate it at the player's location and destroy it afterwards. Next up, we'll add a function to slow down the timescale when the player is hit. This mechanic is extremely common in games like this to give the player some time to regain their bearings after they have been attacked. In the player controller, add a bool, restore time, and a float, restore time speed. Then create a function, hit stop time, and add in 3 arguments, float, new timescale, integer, restore speed, and float, delay. The first thing we'll do is set restore time speed to restore speed, which allows the restore time speed to be different depending on the enemy attacking the player. Then, set the timescale to new timescale. Next, we'll have to create a coroutine to restart the time. Let's call it start time again, with an argument float delay. In here, we'll set restore time to true, and then we'll wait for seconds, delay. In hit stop time, if the delay is more than 0, which means we've been attacked, we want to call the start time again coroutine. To avoid stacking the function if the player gets attacked multiple times, we'll stop the start time again coroutine before starting it. Else, restore time equals true. Alright, now we'll create another function, restore timescale, to, restore the timescale. First thing we'll do is check if restore time is true. If it is, check if the timescale is less than 1. and add time.deltaTime times restore time speed if it is. Else, set the time scale to 1 and reset restore time to false. So if the time scale is less than 1, it'll get faster until it reaches 1. And if it goes above 1, we'll set it back to 1. Then put restore time scale in void update. We'll be calling this slow time mechanic in the enemy script after it attacks the player. Let's set the time scale to 0, the restore speed to 5, and the delay to 0.5. Finally, we'll be adding a flash effect when the player is invincible. In the player controller, we'll add a float hit flash speed. Then we'll add sprite renderer SR and assign it in void start. Then create a function flash while invincible and change the sprite renderer's color to ping pong lerp from white to black if the player is invincible. Else, set the player color to white. What ping ponging does is to change it from white to black and back to white, and keep doing so long as the parameters are fulfilled. Add this function in update. Okay, now we can get to it. Now, let's create some hearts to show the health of the player. Create a canvas by right-clicking UI and Canvas. Set the canvas to scale with screen size. Then, we'll create a script, heart controller. In the heart controller, we'll add using unityengine.ui to the namespace. This allows us to use any UI element in Unity. Next, we'll add player controller player, private game object array heart containers, private image array heart fills, public transform, hearts parent, public game object heart container prefab. The heart containers will serve as a vessel to hold the image of the filled heart. Before we move on, let's create the heart container prefab first. I'll be using these heart container and heart fill images. Once again, these will be in the description below. Set both to clamp and point no filter. Then drag out the heart container image, then drag out the heart fill image. Make the fill the child of the container and set its transform to 0 for all. We'll rename this to heart container and drag it into the prefabs folder. In the heart container prefab, we'll remove the sprite renderer for both the container and the fill, and then add an image component to both of them. We'll assign the respective sprites to the source image. We'll resize the heart container to 40 by 40 and check preserve aspect for both of them. Afterwards, we'll change the image type of the fill to filled and uncheck clockwise. In the canvas, create an empty game object and name it Heart's Parent. Add a grid layout group to it and set the cell size to 40 for both and spacing of 1 for both. Change the child alignment to middle left and constraints to fixed row count of 1. Alright, now let's move back to the script. In start, we'll assign the player and determine how many hearts we'll need, which is the max health. Next, we'll create a function, call it setHeartContainers. Then we'll iterate through the heart containers array to determine how many hearts will show. So if I is less than player.maxHealth, heart containers set active true, else set active false. We'll copy this function below and change it to set filled hearts. Change it to heart fills instead. And here, it will be heartfills.fillAmount equals 1, else 0. Next, we'll create another function instantiate heart containers, then iterate through the max health. We'll create a game object temp equals instantiate heart container prefab. Then set the temp's parent to the heart's parent. Then we'll assign the heart containers to temp. This sets it to the parent's position. Finally, set heart fills to the image component in the heart fill. In the canvas, assign the heart container prefab and the heart's parent. Now, we'll need to update the hearts so when we get attacked, the hearts decrease. In the heart controller, we'll create a function update hearts HUD and add the set hearts container and set filled hearts functions in it. Then add the update hearts HUD to void start. Also, add instantiate hearts containers to it. Alright, there's one more thing we need to do before we test it out. So we'll move back to the player controller and create a delegate void on health change delegate and give it a variable name on health change callback. This delegate void will be responsible for any updates we may need for the hearts. Now, I'm using a delegate void as delegate voids can be used to call multiple methods. I'll be using this same delegate to not only decrease the hearts, but also increase them as well. In the health property, we'll add if onHealthChange callback is not equal to null, invoke onHealthChange callback. Now, in the heart controller, we'll call onHealthChange callback and plus equals update hearts HUD. We're using plus equals here as we are multicasting the delegate, meaning multiple functions will be running at the same time when we call this delegate. Okay, now we can test it out. Excellent, the hearts are spawned in, and if we're attacked, they decrease. Right, now the health can decrease. Next up, we'll create a healing mechanic so the player can recuperate after an epic battle or accidental fall damage. Firstly, in the input manager, we'll change this Fire 2 to healing. Let's use the right mouse button for that, which will be mouse 1. Then, in the player state list, add a bool, healing. Next, in the player controller, create a float, heal timer, and serialize float, time to heal. These will, like the attack player mechanic, limit the speed of healing as we don't want it to happen every frame. Otherwise, it'd be broken. Alright, then create a function, heal. If we input healing and health is less than max health and the player is idle, as we only want the player to heal when they're idle, set pstate.healing to true, else set it to false. Then we'll get the heal timer to increase. If the heal timer is more than or equal to time to heal, health plus plus, and reset the heal timer back to 0. In else, we'll also reset the heal timer to 0. So the healing will reset if the player stops the healing input. And finally, add heal to void update. Okay, now let's test it out. Let's set the time to heal to 1 and play. Excellent! The hearts increase when we heal and we can't heal above the max health. Okay, let's create a healing animation as well. Create an animation clip and name it player_heal. We'll use the crouch sprites for this animation as we won't have a player crouch. In the animator, link the heal animation to player idle. Then, create a bool, healing, and add it to both arrows. Disable has exit time and set transition duration to 0. Now, we'll activate the healing animation in the heal function by setting its bool to true. Alright, let's test it out. Perfect, it works. Now that we have the healing, we'll create a mana mechanic so we can't heal forever. The mana will also serve to limit the spellcasting that we'll be getting into later. We'll create a section, mana settings, and add a float, mana, and a float, mana drain speed. Then create a float property, mana, and return mana. After we get the mana, we'll set it. So if mana is not equal to the current mana property value, then we'll update the mana to be the same. This is just like the health property as well. Then, in the heal function, we'll only allow them to heal if their mana is more than 0. And while they're healing, we'll drain the mana. Okay, in void start, set the mana property to mana, and then we'll play. We'll set the mana to 1 and the mana drain speed to 0.2. Great! As you can see, when we heal, the mana decreases and we can't heal if we run out of it. Now let's add a way to gain mana. so we'll create a float, mana gain. We want to get mana when we attack enemies, so in the hit function, we'll gain mana when we hit anything with the enemy tag. Okay, let's see if it works. Set the mana to 0 and mana gain to 0.3 and play. We seem to have a bug here that doubles the mana gained. Fret not, because this is easily fixed. This happens because we have 2 colliders on our enemy, so when we attack, it's detecting it twice. It's also the reason why the attack does double damage as well, if you've noticed. We'll remove the smaller collider and uncheck is trigger for the other one. Then, in the enemy script, we'll change on trigger stay to on collision stay. Now, if we test it out, yep, works like a charm. Attacking the enemy increases the mana until 1. Next up, we'll be adding a UI element to show how much mana we have. In the editor, we'll create 2 UI circle images. Make one slightly larger than the other and change its color to black. Then rename it to mana container. Afterwards, make the white circle a child of the black circle. Change the image type to filled. Change the fill method to vertical and recenter it if you need to, and rename it to mana. Shift them to the top left hand corner of the canvas. Okay, let's shift the hearts area more to the right so that it doesn't clash with the mana container. Alright, in the player controller, add an image, mana storage. In void start and mana, we'll set the mana storage fill amount to mana. Now, if we test it out, we can clearly see how much mana we have, and it decreases and increases accordingly. Moving on, we'll be creating a set of offensive spells the player can use when they play the game. In Hollow Knight, the spells cast change depending on the direction of the cast, so we'll be replicating that as well. Firstly, in the input manager, we'll replace Fire 3 to cast spell, and let's use the F key for that. For the side cast, we'll be replicating Vengeful Spirit with a fireball. We'll be using the fireball sprites from the Knight pack. Drag out a fireball and create an animation clip. Let's name it Fireball. Drag in the sprites to the keyframes so that it looks good. Next, add a box collider and make it a trigger. Then, we'll name it Fireball. Okay, now we'll create a script called Fireball. In the Fireball script, we'll create a float damage, float hit force, because we don't want the hit force to be the same as the normal melee hit force, integer speed, and float lifetime. We'll default the lifetime to 1. In void start, we'll destroy the game object after the lifetime has passed. We'll create a fixed update and set the fireball to move there. And finally, we'll create an on-trigger enter 2D to detect if the fireball hits an enemy. If it does, deal damage to it. The hit force here has to be negative, otherwise the recoil will be in the wrong direction. In the inspector, make the fireball a prefab and delete it from the scene. Next up, we'll be recreating the Desolate Dive. How we're gonna do this is show a massive fireball and force the player downwards. So drag in a fireball sprite and rename it to Downspell Fireball. Set the rotation to -90 and scale to 10. Then, add a circle collider and adjust it to only cover the main body of the fireball. Make this a trigger collider as well. Add the animator component and set the controller to the fireball. Make this Downspell Fireball a child of the player and recenter it. Then disable the game object. We'll set this game object to true when we cast the Desolate Dive. And finally, we'll do the Howling Wraiths. Conveniently, the night pack also has an explosion as well, so we'll just use that. Drag out the explosion sprite and name it Up Spell Explosion, then create an animation, Explosion. Once we're done creating the animation, we'll add a box collider to it. Make it a trigger and set the Y offset to -0.16. Let's drag the Up Spell Explosion into the prefabs folder. Now, we'll recenter it, but we'll increase the Y position as the explosion is supposed to happen above the player. The value I'll be using is 1.5, but feel free to experiment with whatever value you like. Then, we'll change the scale to 10, and we'll add the Destroy After animation script. Next up, we'll be creating the cast spell animation. Create an animation clip, player_cast. Then drag in the cast sprites from the night pack. Uncheck loop time. In the animator window, we'll link player_cast to idle, jump, and walk. Then we'll create a bool, casting, and add them to the arrows. Uncheck has exit time and make transition duration 0. Okay, let's move to the player state list and create a bool, casting. Now, in the player controller, add a section for spellcasting. We'll define a float, mana spell cost. Let's default this to 0.3, so if we have full mana, we can only cast 3 spells before we run out. Then, a float, time between casts, and float, time since cast to prevent spamming. Game objects Side Spell Fireball, Up Spell Explosion, and Down Spell Fireball. Next, float spell damage. This spell damage will be used only for the Howling Wraiths and Desolate Dive. And finally, a float down spell force, which will determine how much downward force we apply to the player when they use the Desolate Dive. Alright, with all that setup complete, let's create the cast spell function. In the function, if we input cast spell and the time since cast is more than or equal to time between cast and the mana is more than mana spell cost, set pstate.casting to true and reset the time since cast back to 0. Else, increase the time since cast. Next, we'll create a coroutine, cast coroutine. The first thing we'll do is play the animation, then wait for seconds. Now, the animation has 2 parts, the prep phase and the cast phase. As you can see here, we only want the spells to cast when it reaches that point, otherwise it'll look weird. If your animation is exactly the same as mine, then it's 0.15 seconds after the animation plays, so that's what I'll put in. Okay, now we'll create the different spells. For the side spell, we'll only cast it if there's no vertical input or if the player is grounded and is holding S, just like the side attack. We'll create a variable game object, Fireball, and define it to be instantiating at the side attack transform. Then if the player is not facing right, we'll flip it so that it moves towards the left instead of the right. And finally, we'll make the player recoil. Now the upward spell. This one is simply just, if the player is holding W, instantiate the up spell explosion at their transform. Set the RB.velocity to 0 as we want the player to freeze in place when they cast upward. And finally, the downward spell. If the player is holding down S and isn't grounded, set the down spell Fireball to true. After the spell is cast, decrease the mana by the cost. Wait for seconds again, set it to 0.35 seconds. Now this value is the amount of time from the cast to the end of the animation. So unless yours is exactly like mine, it will be different. Then set the animation to false and set pstate.casting to false as well. In cast spell, we'll add in the cast coroutine after we set the time since cast to 0. And then we'll disable the downspell fireball if the player is grounded. And if it is active, we'll force the player downwards at downspell force. Force. We'll create an on-trigger enter that will deal damage to the enemy if they're inside the spell's trigger collider. Finally, put cast spell in void update. Now, we'll assign everything in the inspector and test it out. Epic! It works like a charm. So right now, we have a heart system that will show the health of the player, particle effects that show when the player is damaged, recovery time when the player is hit, a flashing player when they're invincible, healing, mana, and spellcasting. Before we end off, let's clean up the project files. Shift all the scripts we have made today to the scripts folder. We'll also create a spell animations folder in the animations folder and put all the spell animations in there. And I noticed that the particle effects is too fast, so I'll decrease the speed to 50. That's much better. And that's all I have for you in this episode. In the next episode, my partner Kiefer will be covering perspective camera for background, building basic levels, and how to transition between them. Thank you for watching till the end, and I hope you've enjoyed the video. Want to support what we do? You can help us by becoming a Patreon. This will give you access to the project files for tutorials, as well as patron exclusive posts on our blog. Any support you can give will be invaluable to us, as currently we're only making back about 20 cents for every dollar we put into content creation. So your patronage will go a long way to help us make this a sustainable endeavor. See you in the next video.